Good afternoon, everyone. Welcome to live class. Dear students, what are the points we have discussed yesterday? Let's revise first, then we'll move to the next topic. Chapter number 1, number systems. Listen, yesterday we have discussed the points natural numbers, whole numbers, integers, rational numbers, finding between rational numbers, these are the points we have discussed yesterday. We will move to the next point, that is irrational numbers. So what is meant by irrational number? That is the most important. Yes, what is irrational number? Now I will write it here, irrational number definition. Yes. Before going to the irrational number definition, so what we discussed the definition in rational number. Let us revise that point first. So a number which can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. In the irrational number, very simple. Now I am writing. Listen. A number which cannot be expressed in the form P by Q, where P and Q are integers and Q is not equal to 0. This is the definition of irrational number. Now we are moving to the real number. Real number. Real numbers. Yes. Yesterday definition rational number and today definitions irrational number. What we studied yesterday, rational number and irrational number taken together are called real numbers. So what are rational numbers plus irrational numbers taken together is equal to real numbers. Got it? Rational number plus irrational number is equal to real numbers. Now I will write it. We will write it. The collection of rational numbers and irrational numbers taken together are called real numbers. Are called real numbers. It is denoted by capital R. Real numbers is denoted by capital R. So very simple to remember the real number definition. Rational numbers plus irrational number taken together are called real numbers. Got it this point? Is it clear? Irrational number and real numbers definition. We will move to the next point. Listen here. Listen here. Rational number. What I'm writing next point. Rational number. So rational number means it is in the form of P by Q. Means the number is written in the form of P by Q. Yes. That next what I will take it. The next number what I will take it. 10 by, for example, I will taking one example for this. 10 by 4. 10 by 4 we can cancel it, we can write it 5 by yes, 2 2s are 2 5s are. That is equal to 2.5. So this 2.5, so what will get it in the division? So we can call it as terminating. Terminating decimal expansion. One more example in this, we can call it as a 1 and the next one. Listen, I will write it 1 by 3. Yes, if you divide, so what we will get it? 0.3333 dash dash dash. Then you can write it simply that as 0.3 bar. Yes, it is repeating. Yes, no? That's why. So we are taking 0.3 bar. It's nothing but the repeating 333. So when we will divide 1 by 3, you will get it the quotient 0.33333 the continuously. For this, what we will call it as non-terminating but repeating So non-terminating but repeating is the digits are repeating, 3 3 3 3 continuously we are getting. So it is non-terminating but repeating. So on which? On rational number. On rational numbers. So first you must be clear the concept. The first one is terminating, because terminating decimal expansion. The second one is non-terminating but repeating decimal expansion on rational number. The second one, so just I'm moving with irrational number. Listen, in this irrational number, I will consider root 2. So what we will get it? root 2 value is like 1.41 something will get it. And root 3 is equal to, you can divide up to 4 decimal places, you can consider in the root 3 also 1.7320. So what we call it as, these are non-terminating, because keep on getting the reminder, non-terminating, non-terminating, non-repeating, non-terminating, non-repeating. These are non-terminating, non-repeating. And here you can consider example for irrational number like root 2, comma root 3, comma pi, and dash dash dash, etc. etc. The example for irrational number, which cannot be written in the form of p by q. So just explain the decimal expansion of a rational number and irrational number. The first one is terminating, the second one non-terminating but repeating. In the irrational, it is non-terminating, non-repeating. See, 4, 1, 4, 2. The next is non-terminating, non-repeating, decimal expansion in the irrational number. Yes, is it clear? So we'll move to the next point. So in the earlier classes, we have discussed representing rational numbers on the number line, whole numbers on the number line, integers on the number line, natural numbers on the number line. So now we are discussing locating irrational numbers on the number line. So what we are discussing, locating irrational numbers on the number line. Listen, it's very, very important. First, I will write it. Locate root 2 on the number line. This is textbook example 3. Locate root 2 on the number line. Locate root 2 on the number line. So we are locating root 2 on the number line. And also I will explain about root 3, root 4 also that. Okay. Let us study first root 2 on the number line. Listen here. And in the previous classes, you have discussed about rational numbers on the number line, whole numbers on the number line, integers on the number line. Now, root 2 is a representing irrational numbers on the number line. Representing irrational numbers on the number line. Listen here. So first, what are you doing? In this, just you have to mark 0. Yes. Listen here. So I'm choosing the school in such a way that 2 centimeter is equal to 1 unit I am taking. So what? 2 centimeter is equal to 1 unit. Yes, here I will write it 1, 2 and 3. So here to here 2 centimeter is there. Just I am taking as 1 unit. Yes, here to here. First point. The same way on the negative side. Yes, 1 or 2 you can take it. -1, -2. So I am choosing the scale 2 centimeter as 1 unit. 2 centimeter is equal to 1 unit. The first one. The next, same 1 unit, which is perpendicular to the on the line. So we have to draw the 1 unit. It's perpendicular to. So what we have considered first 1 unit 0 to 1. We have to draw the perpendicular line. So now I will take it as A, or you can consider B also, no problem. So now I am taking as A. So this point this is 0 is there. This point I am taking as O, and this is B, and this is also 1 unit. Remember. Now I am joining OB. Listen. Now I will write it here. So what we have done, construction on the number line. Listen. This is a right angle triangle. Which is right angle triangle? OAB. OAB is a right angle triangle. So according to the Pythagoras theorem, hypotenuse square is equal to sum of these two side square. Yes, here hypotenuse is OB square. 1 minute. Here hypotenuse is OB square is equal to OA square plus AB square. OA square plus AB square. This is, we know that already 1 unit, and this is also 1 unit. So we are finding this OB. See, OB square as it is, I will write it. OA is 1 unit, 1 square, plus AB is 1 square. OB square is equal to 1 plus 1. Then OB square is equal to 2. Then OB is equal to root 2. So this root 2 we have to represent on this number line. And what we have to do for that? Listen. For that, so 1 minute. Just I'm explaining in the general that, so we have to take this measurement O to B. Just we have to cut that measurement. What will measure of this OB? We have to cut on that number line. And this root 2. This is the root 2 on the number line. If suppose root 3 instead of root 2, you have to consider. Then I will explain on this diagram. Root 3. How to locate root 3 on the number line. Simple. The next point. So what we have to do is the next point. So what we have, this is root 2. We have to write it. This is root 2. This line is root 2 on the number line. That is between 1 and 2. The next, root 3 on the number line. Locate root 3. Root 3 is a irrational number. Next, listen. So we have to draw, like B as a center, we have to draw one more perpendicular line. Perpendicular. So that is also 1 unit. We can call it as C. Now we have to join this O to C. O to C. Listen, when we will join this O to C, now OBC in triangle OBC, yes, comma, angle B is equal to, this angle B is equal to 90 degree. Means triangle OBC is the right angle triangle. Now OC is the hypotenuse, because 90 degree opposite side is the angle opposite side is the 90 degree. 90 degrees B. It's this angle opposite side is OC. That is the hypotenuse. OC square is equal to OB square plus BC square. So listen here. I written clearly this triangle OBC. I'm not going with triangle OAB, that is completed. So just I'm showing locating root 3 on the number line. I'm considering now triangle OBC. The next, here OC square as it is. OB means root 2. Just now we got it, that root 2 whole square plus 1 square. See, square and square root get cancelled. This is 2 plus 1, that is equal to 3. So what is that is OC square is equal to root 3. That OC is equal to, so just now I shown that how to represent this. Once again, yes, once again listen here. So this point is there, this point, this. So just you have to show on the, draw the arc or cut the arc on the number line dimension. We have to measure O to C. Yes. Now this line it will cut through, that is root 3 on the number line. So what we have discussed, root 2 and this is root 3. Root 3 O to C on the number line. Root 2 on the number line. Same way we can do with the root 4 also. The same way root 4. Listen. Again we have to draw one perpendicular line to the point C. This is, once again we have to join. You can call this point as a D. Then once again we have to draw here. Means join this O to D. And this is also 1 unit. Next, root 3 by applying Pythagoras theorem. Then using once again root 4. Exactly, it will come on that. Yes, measure here to here. Yes, just root 4 on the number line. Just you can see. And the question number 4, exercise. Question number 4, exercise 1.2. It is a activity, spiral root activity. So you can say anything. You can go with the root 5, root 6, root 7, root 8. So we can do that activities also. So now I explain how to look at root 3 on the number line, root 2 on the number line, and root 4 on the number line. Okay. Now we'll move to the next topic. That is exercise. Next topic means exercise 1.2. I will write it here. Exercise 1.2. So in the exercise 1.2, listen, this is very important. Just you can see that. So I represented root 2, root 3, and root 4. You can continue with root 5, root 6, root 7. That is also the activities of spiral root. In the exercise 1.2, question number 4. Now, exercise 1.2, question number 1. The first question, I will read first. Question. State whether the following statements are true. Your answer. Every irrational number is a real number. Every irrational number is a real number. The first one question. Every irrational number is a real number. Okay? Listen here. Every irrational number is a real number. So what we have studied just now about real numbers, rational numbers, and irrational numbers taken together are called real numbers. The statement is every irrational number is a real number. Now the answer is true because the given statement true. All irrational numbers are real numbers. All irrational numbers are real numbers because in the definition itself we have the rational numbers plus irrational numbers are called real numbers. Next, second question in this. In this second question, listen, that second question. Second question. Listen, every point on the number line. Just I'm reading only question that I'm not writing. Every point on the number line is of the form root m, where m is a natural number. Listen question. Every point on the number line is of the form root m, where m is a natural number. So every number on the number line, 1 minute. Every point on the number line is of the form root m, when root m is a natural number, where root m, where m is a natural number, so the statement is false because as negative integers, the square root of negative integers are not a natural number. Yes, as negative integers, its square root means its square roots are not a natural number. Okay, I will remove that part. Listen here. The next third question. Every real number is an irrational number. Every real number is an irrational number. This is the question. Every real number is an irrational number. So what we have discussed the definition. Rational number plus irrational numbers is called as real numbers. They are saying every real number is an irrational number. Every real number. So the statement is false because as 2 is a real number, I am writing real number instead of rational number, real number, but not irrational number, an irrational number. So these are the 3 points. So we'll move to the question number 2. Listen. First we will read what is the question number 2. Listen here. Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. The answer is no. The second question, they are asking give example. If no, square root. Listen here. Square root of positive integers square root of positive integers are not irrational. Example. First one, root 4 is equal to 2. 2 is a rational number. Or I can go with second one, like root 9 is equal to 3. This is also is a rational number. Third one, root 25, that is equal to 5. Square root of 25 is 5. 5 is a rational number. So that's why we are saying the square root of all positive integers are not irrational. Some are rational. Okay. The next, the last question, that is question number 3. So that question number 3, represent root 5 on the number line. The last question. Question number in the exercise 1.2. Locate root 5 on the number line, or show root 5 on the number line. Listen, root 5. Show root 5 on the number line. Next, once again, you have to draw the line. Listen. First we have to consider 0, and 2 centimeter is equal to 1 unit. Already I said that. 1, 2, 3. So this is 0. And negative also you can consider. So not necessary for the negative values, just to consider 1. So here to here 1 unit, and this is 1 unit. Yes, just this point as O, and this you have considered as B. So here to here 2 units. Yes. Next, representing root 2 on the number line. Now we have to draw perpendicular to the on the number line the second unit. So we have to consider as 1 unit. So we have to draw one perpendicular line. We have to consider this as a point A. This is 1 unit. 1 unit. Now I am joining this presenting root 5 on the number line. Root 5 on the number line. Listen, I will explain here. In triangle, so this is B is 90 degree. In triangle OAB or OBA, angle B is equal to 90 degree. Angle B is equal to 90 degree means OA 90 degree, opposite side is hypotenuse. OA square is equal to OB square plus AB square. What we have measured here? OB is 2 square. OA 1 unit, 1 square. Here 2 units, 2 square. That is 4 plus 1. That is OA square. Then OA is equal to root 5. So this is OA is root 5. and this measure is there, no? So we have to show on the number line. So using the help of compass, this is called as compass. We have to represent √5 on the number line. See. Yes, listen. This is √5 on the number line, or you can write it here to here. So from this 0 to here, √5. Is what it will cut here. That sorry, what it will cut here. The distance on this 0 to here, where that arc is cutting up to there. Got it? So we completed today the topics we have covered in the today class: irrational number, real numbers, terminating and non-terminating, the decimal expansion, locating irrational numbers on the number line, exercise 1.2. The remaining syllabus will continue in the next class. Thank you so much.